Just waiting for the confirmation here. I think it's just buffering. All right, my bad. Okay, so let's take a look right now. I'm going to share screen just in case you don't have the book right in front of you. So here's the workbook. Oh, let me go back to here. Remember, if you don't have the workbook, there's the link to it. Jay could throw it in the links as well. All right, so if I go here, oops. All right, let's go down here. I think we're getting close. Sorry for the scrolling. We're right. Oh my gosh. There we go. All right. And so in this case, I'm going to annotate on the screen. We're looking at this stuff right up here right now. Okay. Now, one of the things that you'll see in different physics books, you'll see different ways of doing this. So I've tried to show you both ways of doing this. Like I said, the handout that I already linked is also going to show you both ways of doing this. And what do I mean? When we talk about mass in physics class, like let's say, what's the mass of that basketball? We usually give it in units of kilograms. Some books would say mass has dimensions of mass. So this capital letter M in the brackets means something. Okay, so now I want you to be careful here. For this class and for the next couple of classes, you're going to see that it's going to make a big difference to me whether you write something as V with brackets or V without brackets. Those brackets have a meaning. All right. For example, look at this down here. Hopefully you could see this. This symbol right here means the units of M equal kilograms. So that's what that sentence says. Versus this sentence, which says the units of X are meters. Notice M with an italics is different than M without an italics. And you're going to see this forever. And I wish there was an easier way because that's very hard when you're handwriting. But I want to point out that meters and mass are two different things, even though they both have the same letter M. And so we're going to try and be very clear with this, and I'll show you some ways to do that in just a second. But so, all right, here's another example. Let's say we have this term velocity here, or speed, right? So here, the square brackets mean the units of, the units of. All right, and I think that's, so that's where this is in the book, and I'll do some examples on the whiteboard here really quick. Whoops, let me get me. All right, there we go. All righty. Oops. All right. So let's say we have some physics terms, like d might be a distance, right? Now, for most of you, if we were talking about a distance, you'd probably say, oh, do we measure that in feet or centimeters or maybe inches or miles? You could say kilometers, all kinds of things, right? But I do want to point out that any one of these units could be converted to meters, all right? And so in a physics class, what we'll do is we'll say the units of D, or the dimensions. You're going to hear me say units. The dimensions, I tend to say units. The units of D. So that's how you would say this phrase. What are the units appropriate for the symbol D? That's what that means. And then I'm too lazy to say all that, so I just say, what are the units of D? Okay. We use this trick all the time in physics to check our work. So it's an important step we've got to learn. And I just want to make sure we're all communicating the same way. It's not that tricky, but we do have to get this right. Okay. So in this case, you would say, the units of D equal meters. Or if you didn't like that, some people and some books would say L. So this means units of length. Now, both of these are fine, but from a practical standpoint, I almost always use this one. And then nobody writes out the whole word meters. So we just write lowercase m. And here's where it gets tricky. You can't really tell if this is meters or kilograms unless you read the whole sentence. Here, I know I'm talking about a unit of distance. That's why it makes sense that this m means meters instead of mass. Okay, and so we see this is going to be pretty annoying at first until you get used to it, so we're going to have to practice a little bit. I'm going to pause for a second and see if there's any questions. Looks like there's nothing in the chat. Remember, at any time you can chat with Jay. Thanks. Hey, everybody, let's give Jay a round of applause really quick. Thank you, Jay, for all your hard work. I appreciate it. And then go ahead, keep those questions coming to her or add it in the chat. All right. All right. Yeah, basically, Dominic, the brackets basically mean units of. And so I got tired of writing what are the units of all the time. So I just use that notation and it seems to work. Good comments. Okay. So now let's try a little bit trickier question. Let's say we had X in meters, or we could say it like this, the units of X equal meters, and we could say T is in seconds, right? Or the units of T equal seconds, all right? So let's say we have this, and now let's say we have an equation where we say X equals 1/2 AT squared. The way we use this is as follows. Let's say I want to figure out the units of this term A. Okay, this is the practical way you use units. So what I would do is I would say, well, I could take the units of everything. And if you've already done this, that's cool. Give me some time just in case. There's a lot of people that have never done this. I'm going to take the units of everything on this side, one step at a time. And if you want, you could be writing this out with me. All right. And now we're going to learn some weird stuff. When you punch in 1/2 in your calculator, I'm guessing you've never thought about 1/2 miles, 1/2 inches, any of that. And it's because the number 1/2 by itself has no units. And now we have to be careful. In math, you might think, oh, no units. Isn't that like the number 0? In unit math, no units is like the number 1. It has no effect. Think about it. 1/2 of whatever this crap is going to have the same units as all of it. And so I want you to watch out. The units of these numerical factors, unless otherwise specified, are always no units. Now, for unit math, this is really cool. They just disappear. Think about it. If this has no units, it's not going to change the units. So at this point, I'm going to write this. We just get rid of it. So in this case, now I don't have to think about that anymore. That's cool. Think about a negative sign. A negative sign, that's the number -1. That's the same thing as not affecting the units. If I have negative dollars in my bank account, well, it's still dollars. It's just not as fun. Okay. So in this case, now take a look. Let's say I want to figure out the units of A. Watch this. This term disappears. I would say the units of A are going to equal the units of X divided by the units of T squared. And I'll get all this stuff in here now. The units of A, right? I'm going to divide this to the other side, then flip the sides. So A is going to be X over T squared, and then I just put the A on this side. I'm going to pause for a second. Again, I just moved this underneath, and then I flipped them on the equal sign. Oh, there's a little better. I'll see. There's a chat question there. Okay, I think I got that already. All right, so now in this case, now I'm going to plug in this junk from up top. Oh, whoops. Right about there. Now I can plug in this stuff. In this case, the units of X are meters. The units of time squared, that's going to be seconds squared. When you square the number, you also square the units. Remember, this is just like algebra. Like if you had 2x and then you square it, you'd have 4x squared. In this case, if you square the time, like let's say you square 3 seconds, that would be 9 seconds squared, not 9 seconds. Okay, so this would be seconds squared. And so what we have done is we have now figured out the units of A are meters per second squared. Somebody else might write this. This is equivalent to, if you're using the other notation, units of length over units of time squared. And I think that's how I wrote it. Yeah. So again, I'm just showing you up here at the top. There's different ways to write the units in different times. Like time, you could either write just seconds, which I like, but some people really like this other style. So I'll leave it like that. What do you think? So far, so good? Just pause and get a quick check. I have no idea if I'm going too fast or if this is about right. Just give me some feedback. Is this okay?
Yeah, quick question. So
Yes.
you moved everything that was defined to the right, so you could define A. Was that pretty much what you did?
Oh, yeah. Yeah. So regarding this, whoops, let me get my screen up again for the live stream. So what I did here was I'm gonna race and just do it again really quick, really fast. Okay. This is how this problem would look at full speed. You'd say, okay, I have x equals 1/2 at squared. My exam question says determine units of a. And I might say it's something like this: determine units appropriate for uh, the variable a. Okay. So that might be what it looks like on test A or something like that. Okay. And so what I would do is I'd say, okay, the units of x equal the units of 1/2 times the units of A times the units of time squared. When you have this, you could either leave it inside or outside because it doesn't matter. So I'll try this one different. I would say, oh, this thing doesn't matter. Now I'm just going to say the units of x equal the units of A times the units of t squared. Now I'm going to divide that through like that. I hope that makes sense. And then nobody writes it like this. All I did was just flip it, which is meters per second squared.
All right, gotcha.
Was that good?
Yeah,
Yeah,
thank you.
thanks. Thanks. Good question, Christian. All right. And so this is the kind of way you might see that on a test day or a test question here. There's also another level of this, why we actually care about this. And I might point out if you've got your quiz or your workbook, look at 1.34C. And I'm going to bring that up here as well and just hold it up for a second. 1.34C, I think it's this one. You look at that crazy equation, it says x equals a bunch of junk. And I'll get it even closer there. Whoops, sorry. X equals something like SAT over V minus some square root junk. The idea is here's a real way we might use this. Let's say you got that as an answer to a chapter 5 question or a chapter 21 question. There's a way we can use this to at least get a check on your work. Because as engineers, it's very difficult to know if you're doing things correctly. We want to have as many ways to check our work as possible. So I'm going to look at that one up on the board, and then I'll probably set you free to do some problems here, or maybe we'll do one more version here. So let's say we had x equals, oh, and this is 1.34 part C. Okay. Now, and I look in this problem, I'll hold it up here. I notice that there's this giant table right here telling me all the units. So this says time is going to be measured in seconds. This mass is in kilograms. This other mass, capital M, is in kilograms, et cetera, all the way across. So this chart is like some experimental data that some student took in a lab, let's say. And now what I'm saying is, well, if I use this equation with it, let's see what's up. Oh, and then yeah, Okay, I'll keep going, and then Dominic, I'll come back if Jay didn't answer your question for you. All right. Looks like she got it. All right, so I'm just writing this one up. Let's say S. Okay. So now we're getting more and more complicated, right? More and more complicated. The question for this one says, explain why this formula cannot be correct. Hint, check the units. So if we check the units on this thing, what we're going to see is this probably doesn't make sense. How do I know an equation makes sense? You've probably heard, well, you could only add apples to apples. Well, in this equation, we have three things. If they're not all apples, it doesn't make sense, right? You can't have apples minus apples equals oranges. That's not going to work. You can't have apples equals apples minus oranges. So everything has to have the same type of units. So what we're going to do is, instead of trying to plug in a bunch of numbers and do the math, all we're going to do is we're going to look at the units of each term and make sure they match. If they don't, that helps us find out where I made my mistake. And that's why this is actually useful to engineers in the real world all the time. Okay, so let's check. What are the units of this term? If I look in that table, it just says, look at the units and get X. That's probably meters. Where is it? Right there, meters. So that one's done. What this tells me is now, aha, I know everything else in this equation had better be meters. So now I'll look at the next term by itself. Let's look at the units of SAT over V. That's kind of weird looking. In this case, that's going to be the units of S times the units of A times the units of T divided by the units of V. And I think we know all that stuff up there. Again, sorry, just looking at this table, this is where I'm going to get the values. So I'm going to look through this table and look for what the dimensions are for each of these, or the units. Okay. So in this case, S is in meters. This is in meters. Notice this. After I write it in units, I get rid of the square brackets. That's one of my pet peeves. This says the units of S. The units of S equal meters, not the units of meters. So once you do the units of, you get rid of the square brackets. I'll say it again. Once you do the units of, you get rid of the square brackets. So the units of S are meters. The units of A, I'm assuming that's acceleration in meters per second squared. It is. Here's a tip, people. I know you're used to doing diagonal fraction bars in a lot of classes. As soon as you get lots of complicated fractions and fractions within fractions, stop doing diagonal fraction bars. Only do horizontal, okay? Why? Because it's easier to see the reciprocal, and if you're looking at it later, it can look like a denominator maybe isn't in the denominator. You might miss it. It's just harder to screw up if you use a horizontal fraction bar. It's just a trick. It's not like it's required. I just highly recommend it. T, that's going to be seconds. It's got to be, right? Yes. And then V, it's going to be meters per second. This one's looking pretty nasty, right? Do not overthink it. Take the time to let the paper do the work. I know we're all online, and I know you think, oh gosh, I don't ever need paper again. Just please, 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 I'm begging you, start writing stuff on paper and let the paper do the work for you. I find I make fewer mistakes by writing things out than by trying to do it in my head. You guys are not stupid. You're probably the best students on campus, or going to be soon, right? Engineering students are typically the best on campus. So you're used to being fast at things. Well, here's the trick. You're going to be faster writing things down and having to do it once than doing it in your head 3 times and keep screwing it up and getting angry. Okay. So look, multiply by the reciprocal to get this junk out of the basement, right? Don't overthink it. Let the paper do the work for you, and you'll make fewer mistakes and take this class fewer times. That's our goal. Get you out of here, get a job. Now, Now I've got everything in the top. I can kind of, let's see, this meters will cancel that meters. It looks like I have seconds canceling seconds. And then it looks like I have, what is this? I'm getting kind of lost here, so I'm going to read it. This is a 1/second squared times 1/meters, it looks like. And so that gives me 1/meters second squared. Now, hopefully I didn't screw that up. Let's just go through it. Meters per second squared. I think I forgot to cancel. Oh, no, this one. I did. I screwed up. Do you see that? I totally screwed up. I wrote too much, even with the paper, but I was able to catch it when I looked at it. I tell you what, I'm going to start over and do this again because there was too much there. Let me write it out a little better. I've been doing this 20 years and I could still screw up, so I think you can too. Let's do this a little bit better. We've got meters times meters per second squared times seconds all over meters per second. Then what did I do? I multiplied by the reciprocal, and it starts to get so long and ugly. Let's do an extra line because you could see I was just telling you, let the paper do the work, and then I didn't. And I screwed up. This happens all the time. So now what I'm going to do is I'm going to make all of this look like a fraction. This is meters divided by 1 times meters per second squared times seconds divided by 1, right? Times seconds divided by meters. And so in this case, let's see what we get. Seconds squared, meters, we do get the right units of meters. And you could see, hopefully this makes a little bit of sense. If you try to add in diagonal fraction bars, that's even more confusing. So I really like the horizontal fraction bars there. This term has the right units because it matches the other term. I bet this one's not right. I'm going to pause there, and sorry I screwed that up. Whoops. Okay, okay. Let me see. How's everybody doing here? Is this making some sense? Okay, good. Let's get the other term, and you can race ahead. And like I said, at any time, if this is easy for you, go ahead and just start doing this page and start working, okay? Let me go back to here. All right, so now I just want to point out we got this one done. I need to make some space on my board. I know you can go back on the YouTube video if you need it. So I'm going to erase this. And we know we just figured this out. So these two match. Now we're left with just this one. Hey, everybody, remind me, think to yourself, does the minus sign matter at all for units math? Think to yourself, does the minus sign matter? No, that was the answer. It's like a -1. -1 has no units. It's not going to matter. So with unit math, this is a really cool thing you can do. You can ignore minus signs in unit math, only unit math, obviously not real algebra. And now we're almost up to full speed here. Okay, that's going to be the units of t times the square root of the units of m divided by the units of force. And I know we're skipping ahead here. We're just learning the units. Sometime you might notice this. You see, I have this habit of drawing this little hook on the end of my square roots. The reason I do that is when I'm doing long homework assignments, pretty soon you're going to see you get a whole bunch of junk in your square root. That just tells me that's where I ended the square root. It's just useful for me when I'm writing on paper. So if you're wondering why I do that, that's just to tell me where is the end of the square root in my writing. Okay. All right. So now let's plug this in. This is going to be seconds, right? I get rid of the bracket. The units of t were in seconds in that spreadsheet there. The square root of the units of m are, think, kilograms. So the units of x are m. The units of m are kilograms. One more time. The units of x are meters, or m. The units of m, which is a mass, are kilograms. Ah, don't you love physics? Okay. Now I'm going to read the chart here. Force, it says, is in newtons. Now, this is our first time seeing what a newton is, so I want to point out that's also written up here. Force, which is a newton, is the same thing as a kilogram times meters per second squared. So you're supposed to know that this is true, and it's also, should be somewhere back here. I don't know. I think it's somewhere in this worksheet on the back, or if not, that's something that we're going to use so often. I want you to know that, okay? So remember where this page is if this kind of question shows up on your quiz. Agreed? You know where all your units are right there. So I'm not going to write it as a newton. I'm going to write it as a kilogram meter per second squared. And you've probably noticed I'm a little loosey-goosey with where I draw the fraction bar. As long as they're equivalent there, that's fine. You could change it to, for example, right? There's no difference between writing it that way or writing it like this. They're both the same, okay? Now, I could see, I'm just going to carry this down over to here, all right? And this is kind of in my way. So now it's S times the square root of kilograms. I'm going to let the paper do the work so I don't screw up again. I'm going to multiply by the reciprocal on the top and the bottom. Now I know where my square root's supposed to end. Okay. In this case, the second squared drop in the basement, the kilograms drop in the basement. And so this gets me just a one fraction instead of multiple. That's the trick. Don't try to be too tricky. Oh, wait a minute. Was this? Oh, yeah, this is seconds out front. Okay. Now I also can see the kilograms cancel here. And it looks like I get seconds times the square root of seconds squared per meter. And no matter what you do, you could even say, oh, well, this is equal to seconds squared over the square root of meters, right? Because the square root of seconds squared would be seconds. That would come out. Second times a second is back to seconds squared. Crazy, right? But the clear thing here is it's not meters. This was in meters. This was in meters. And this thing is not in meters. This is the problem. All right. And so if you were doing your homework, that's why you would do this. You'd be like, huh, this is the answer I got, but I'm not getting the right answer when I punch in the numbers. What am I doing wrong? Check the units and you'll see if you maybe flipped something upside down or forgot to cancel something earlier in your work. All right. So I'm going to pause for a sec here and maybe take a look. I see there's a question in the chat maybe, or, oh, Edgar got it. Okay. Oops. Let me make sure here. I saw this one. Okay, so I'm going back to Dominic's. Dominic, you had little t and big T, or do they both represent time? It depends, Dominic. Usually little t is time. Big T is either tension or time, as in period, to orbit a circle. But you'll find I use a different capital T for period. So yeah, that said, if you're using what some books call this other dimensional analysis as opposed to unit analysis, which I say, they would say the units of T, another way to say that would be the units of capital T. And it's just one more tree. And see, this, it starts to get confusing because for me, this makes me think about tension and I don't like that. That's why I immediately go to these units. And that's the kind of thing you would discuss with another human being is you'd actually talk about what units you were measuring in. Yeah, and I'll leave it at that. And hopefully that addresses yours. Edgar, the 1/2 matters if you're plugging in numbers. But remember, like, let me say it like this. And I think you got your question answered, but I'm just double checking. So my apologies. Let's say I had 6.0 6.38. Oh, let's make this easier on myself. How about 6.00 meters? If I take a half of that, the answer would be 3.00 meters. And I see that multiplying by 1/2 does nothing to the units of what I multiplied. If this was meters per second, I'd get meters per second. If it was meters squared per seconds cubed, I'd get meters squared per seconds cubed. We see that the 1/2 has nothing to do with the units of the other stuff. So that's what I was trying to get at with that issue. Hopefully that's good for Edgar, why that doesn't matter. Okay. All right, and let's take a look. So Dom's good, Edgar's good. All right. Did I miss anybody else? Any other questions? You can unmute or just throw it in the chat. All right, you guys are kicking ass. Let's do one more problem. I'll set you free for the rest of the day and just let you do work, all right? Because I want you to see one more way we might do this one. Let's look at 1.36. A lot of students tend to have trouble with a question like this, and I'll show it up on the screen here in just a second. And I could go to the book if we need to, but right there. So the idea is you got this ugly equation, and this is a very common way of phrasing exam questions. So this is, I don't know, I just like this way. All right, so there's the question. You've got that equation, and we're going to try and figure out the dimensions or the units of A and B. This happens so often in physics. It's like a skill you got to have on autopilot, okay? So I think what I just said was what question? 1.36, I think. Yep. So in this question, we're given F equals AX minus BX cubed. All right. And now we're supposed to get units of A and units of B. That's our goal for this question. All right. Now, how would I do this? There's a trick here. You could try and do algebra and solve for the letter A, or do algebra and solve for the letter B, and that would work. And then you could do units, but it's a lot harder. Remember this trick. The units of this must equal the units of that. Also, the units of this must equal the units of that separately. The idea is you can look at these two terms and compare them and say, well, these units must equal those units. Be careful. F does not equal AX, but F equals AX. What? F does not equal AX, but F, units of, equals units of AX. So there's a big difference between saying F equals AX and solving for A. That would be completely wrong and bad. But if we say the units of F equal the units of AX, then we can flip it around and solve it without having to worry about this other stupid term at all. And it's much easier. So hopefully you could see here, I hope you could see that the units of X, wait, what are we getting? The units of A. That's going to be the units of F divided by the units of X. Now be careful, look what I did. I moved the X underneath, then I flipped the sides. I'm going to do this so many times to you. You got to get used to this. Again, I moved the X over here, and then I just wrote it by flipping the sides because we usually want to solve for A. When you see in the solutions, I do this all the time. Okay, so now the units of force were newtons, and the units of X were meters. Another way, so that would be a valid answer. We could also plug in that this is kilogram meter per second squared divided by meters. And I'm going to just multiply by 1/meters on the top and the bottom so I don't screw it up. I mean, it's pretty easy. You saw I already screwed one up today, and I've been doing this for 20, 30 years. So it's really easy to screw these up if you don't write them out and take your time. Meters, 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 meters. So it looks like another unit would be kilogram per second squared. And so I will write that that's the units of A. Okay. And if you were doing it the other way, remember that this would be, some people might write the units could be expressed as dimensions of mass over dimensions of time squared. So these would both be the same. This is another way to write it that drives me crazy, so I don't do it that way. All right. Um, and yeah, notice these ones you're supposed to keep the brackets. These ones you're not. Whatever. One more thing that makes physics fun. So that's how you get the units of A. I have a feeling you could figure out how to get the units of B. You say the units of F equal the units of this thing. Do I need to worry about the minus sign? No, because it's a number and it doesn't matter, right? Negative $3 is going to be the same as positive $3 as far as units go. It's money. All right. Let me get out of there. Come back into here. All right, and maybe I'll pause for a second. Is everybody doing all right? Okay, and so there's another cool thing that this is useful for. I don't know if any of you are aerospace. I've already forgotten. I graded 110 of those dumb quizzes the other night, and I've already forgotten who was in which class and who was aerospace and chemistry. I think there was a lot of chemistry. So if you heard me making fun of chemists the other day, keep in mind that I actually like chemists, but I'm still going to make fun of you, okay? That's just what physicists do. And a lot of my former students that had chemistry, they've appreciated the work that they got out of this class, believe it or not, all right? And so I actually think you're going to be in a really good position when you get to PChem as an upper division, physical chemistry. Yeah, you'll be ready for it. That's what my former students have said. All right. Okay. So I know this maybe seems a little boring, but I'm a physics teacher. I want to show you why I like this too. Let me get this in here. So for me, this is where it gets exciting. I'm going to scroll forwards a little bit, and then I'll tell you which problems are good and we'll set you free. Now look at this, physics and aerospace majors, right? So it turns out those two majors, this kind of stuff comes up all the time. One of the reasons scientists will use dimensional analysis is they can literally figure out, for example, in this one, let's say you had this ball and it's swinging back and forth, and you want to learn about what are the factors that affect the period. And so here you can see where capital T is time in this case, all right? So does the length of the string matter? Does the mass matter? What are the different parameters I need to test? So maybe you think, well, maybe the amount of gravity matters. Maybe the mass matters. Maybe the length of the string, and maybe what was this? The amplitude, how far I pull the string over here. So you can see the A. And what you could do is you could do this unit analysis and figure out some things don't matter. All right. And so this is not going to be required, but if you're a physics major, this is how a physicist or an aerospace major might reduce parameter space, which means in the practical world, what are the things that we need to modify to learn about this wing so that it's safe for the community or for the public? What are the things I need to test? And you'll discover sometimes that some things don't matter. So, and a big thing that was discovered was the Reynolds number, and you can learn about that here. These are from the recommended problems. So if you don't want to do this, don't do it. All right. But I find that very interesting. If you're a physics major, you should definitely do it. Okay. All right. I think we've covered everything we need up to 1.44. That's awesome. So that's it. I was going to just stick around and answer questions. We've got another 40 minutes or so. So I think you should just work and answer questions. If you want to leave Zoom and pop back out, that's great. I'm going to stop the live stream now.